Vector magnitude, we're going to look at exact and estimation. So let's begin with let's be more precise with vector magnitude. So up till now we've just estimated. So let's look through it. So it's necessary first to review the Pythagorean theorem. Remember, that is a squared plus b squared equals c squared. For our purposes, it will be more practical to rewrite the problem so we solve for the hypotenuse, which, as you may recall, is c equals the square root of a squared plus b squared. So let's look how we might apply this. All right, so here's an example. On this vector, we have a change in the x direction of 7 squares, 7 units, and a change in the y direction of 5 units. So our component form is written with 7, 5. We're going to use that information to get the exact. So remember that this is much like a triangle or a right triangle where you have the side A, the side B, and the side C. So x will be in the position of A and y will be in the position of B. Doesn't really matter the order, it's all good. And remember that if it's in a negative direction, to make sure that you put in the correct way in the calculator. But for now, it's good enough to see how to do this. So we'll take the square root of 7 squared plus 5 squared. And if we do the inside of the square root, we get 74. So that is 49 plus 25 is 74. And then if we put it in the calculator, we come up with a decimal that goes 8.60, and it goes on and on from there. So what I've demonstrated here is if this value here comes out as a decimal, then we have an approximation. We just round it to the nearest hundredth. And then this part right here is the exact. So we leave it with the square root intact. So on your homework, you'll need to be able to type in the square root. Remember that, and the instructions tell you this, that the square root, if you type in \SQ RT and then press any key after that, it will turn it into this feature here. That should be enough to get you going.